All right, I'm going to see if I can do this lesson rapidly because Minnetonka right now is playing, and you guys didn't decide to go to the game, but I want to be able to try to put that up at the end of the hour. So let's see if we can get through this quickly. But I'm not going to short you. You need to know how to do this. That's a third root. That is squared. And what does that negative in the power do? Flips it. Would you please figure out what the answer is? You gotta learn all this stuff before I can get us into the work time and let us watch the Minnetonka girls play in the state tournament. All right. Good guess. And right. It can be both. Yes, 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 yes. All right, so sure, check his answer and then turn it my way. That's cheating, I saw you. All right, this third root, that was 3. Squaring it made it 9. That made it 1/9. All right, that's the critical part about our exponents. So what if it had said n to the negative 2/3 power is equal to, and let me think about this, 1/4. How would you solve it? That's the stuff for today. It's like, okay, now that you understand what a fraction exponent is, what if you had an equation with that in it? All right, the first thing you look for is, could I add something to both sides? Would that help at all? No. Could I subtract something from both sides? No. Could I multiply by something on both sides? And don't think putting it to a power is multiplying it. No, we aren't going to multiply or divide. Do you notice I'm going through the order of operations backwards? We didn't have add or subtract that we could do to solve this. We don't have any multiply or divide we can do, but we can do an exponent on both sides. There's an exponent to deal with, so you put it to the power of negative 2/3. No, wait. Don't I want to flip it and multiply by negative 3/2? If I put it to the negative 3/2 power on both sides, do you get that these two are reciprocals and they will therefore cancel each other when you multiply them? And it'll turn into positive 1. And n to the positive 1 is just n. So all in one step, I'm done. If I can do these 3 parts of it, can you do the square root of it? Can you flip it? And can you then put it to the 3rd power? Okay, so square root of 1/4. I get it. That's tricky. So then I'm going to personally choose to do this one first. I'm going to do the flip first, because do you get that just changes it to 4? And then I'm going to do the square root part, which would make it square root of 4, which would be 2. And then I'm going to put it to the 3rd power, which would make it 8. And there's your answer. But in a vicious twist of fate, there's 2 answers. Yeah, this class got hard, because you had to not only put this to a power that's got a fraction exponent in it, you had to remember that that really means you took a square root on both sides. Do you remember problems where you took a square root on both sides and you end up with an absolute value thing? Oh my gosh, we're doing that again? Yes, we are. And I told you this is going to come up in pre-calc like 8,000 times. When you get this and you go square root, do you remember it was absolute value of x? Remember me saying that was a big deal? Well, it's the same thing, because even though the problem might not be doing a square root like that, it's going to be doing a square root like this. So if you ever put it to a power where there's an even number on the bottom, yeah, it only matters if they're even numbers, because a cube root, you can do negatives with cube roots. Cube root of negative 8, it's no big deal. We don't care. It doesn't crash. So it only matters if you're doing a power that has an even root. Then you've just square rooted both sides, and you need an absolute value. Why does that matter? Because then the answer isn't just 5. It's 5 and negative 5. Do you get how easy it would be to forget that little thing in the middle of a problem? I know how easy it is, because I explained all of that and then gave kids a problem right after I just explained it, and half of them forgot it. One problem later. Try not to let that happen to you. All right, so here's another one. Cube root of n minus 4 is equal to, let me think, I want to make this work out nice. Negative 1. All right, everybody write that one down. And your first step should be to think, in the PEMDAS thing, you always start solving equations by looking for anything you could add or subtract. Okay, dice of destiny. What should I add or subtract? This is row 6, person 1, 2, 3. That's you, Isaac. Plus 4, good. You add 4 to both sides. Cube root of n is equal to 1 minus, or negative 1 plus 4 is 3. And then I'm going to do a critical rewrite. Notice this is the same exact thing, but it's a smarter way to write it. Did I do something to both sides? Nope. I just rewrote this red one as this blue one. Everybody do that. That's one of the things that just doesn't come naturally. You got to kind of practice that. Whenever you see a square root or a cube root or a fourth root or a fifth root, put it on the bottom. Now, kids commonly will say, just times it by 3. Nope. You say, put it to the third. Put it to the third. And now, that is just n to the 1, and n to the 1 is the same as just n. So that's just n. 3 to the third, 27. Did I just do a square root on both sides? Nope. I just put both sides to the third power. That is not the same. There's not 2 answers. Yes? If it was over 3. Oh, if we had had a fraction power like that where we had done the fourth root on both sides, then there would have been 2 answers, yes. Let me do one like that, and then you can all see what he's talking about. All right, so we're going to say, there. This one actually is just what you just said. Step 1, row 5, third person. That's you, MR. You got the easy one. What do you do? Miss Rhodes? Correct. And then I have this weird thing. Who can handle the weird thing? I bet you can. Do you know how to rewrite that weird thing so that people will understand it better? That would work. Can you just make it 1 power? 1 fraction power? Yes. N to the 2/3. Notice we didn't do something to both sides. We just rewrote this weird looking thing as a fraction power. That's not a question. It's just a hand that's elevated. Okay. So now some kids would say, times both sides by 3. Nope. Put both sides to, and be careful. What do you think we're going to put both sides to? Not just the third. 3 halves. 3 over 2. Yes. Now, finish off your answer. I'm going to pause for a second. Think about this. All right. Remember me saying that when you take the square root on both sides, you get 2 answers? Who forgot the plus minus? I know some of you did. Thanks for being honest. All right. Some of you actually caught it, which is fantastic. So it is plus and minus. And what is the answer? Is the answer 4? No. I take the square root of 4, which is 2. I put it to the third, and that's 8, and I have plus and minus 8. What I'd really like to see, I wouldn't mark it wrong if you forgot to do this, but is the absolute value, because that's what's really happening. And then the answer is two things. N equals 8, n equals negative 8. Two answers. Now, if your life depended on it, I gave this example enough times, I won't repeat it, but your grade does depend on it. You could check these. And if you're like, I'm not sure if this is one of those kinds where I could have two answers or not, you can imagine yourself on the test like that, and you're like not sure whether you did that right and whether they both really work. Try putting in the negative 8 right here. Do you get it's going to get squared, and it would be just like putting in an 8? You see how that, if 8 works, then negative 8 would have to work. Now I know you'd be like, but wait a minute, then when you do the cube root, it doesn't matter. As long as at some point that gets squared, the negative or the positive would come out the same. Yes?
I'm just confused how the 4 to the power of 3 over 2 becomes.
All right. Tell me this. Do you know that means the square root? Okay, then what's the square root of 4? Okay, and then we put it to the third.
Okay.
There you go. Yep, 2 to the third ends up giving you that 8. All right, here's one more like that. Ready? Let me think. Yeah, that'll work. There. Solve. Yes? Let me just show you something. I would give you this, the squared could be underneath there, or the squared could be here. And yeah, there's something to do with those powers simplifying, but they don't just cancel each other out. They simplify. So that's going to be n to a power, but it's not just n to the 1. All right. So you can do it that way, or you could put the n squared in there. And either way, it works the same way. So there's something to do with that. Pausing again. Okay. These problems can be confusing, but you just have to take one step at a time. It's kind of like the old how do you eat an elephant question. Just one bite at a time. I'd like to think of it as an elephant made out of chocolate. It'd still be one bite at a time. All right, so I'm going to start with this little bite. Is there any add or subtract I could do? Yep. So I'm going to subtract 6, and I'm going to get this weird looking thing, which I don't want to deal with really, but I will later. There, I did one step. Next, I got to deal with the weird thing because there's no multipliers or divides that I can do, but I do have a weird exponent to fix. So did you notice that this is the same as n to the 2/4, which is the same as n to the, anybody can simplify, right? 1/2. You get what just happened there? If you didn't catch that, the root goes on the bottom, just like in plants. Remember me saying that before? The root part goes on the bottom, like plants always do. Yes? I don't think you're going to get the right answer, but we'll see. Try it without simplifying. It might still work. It's just easier, that's all. Once you realize you can simplify it, do it, because like 2/4 is harder to deal with. The big numbers are bigger. 1/2 is the same as 2/4, right? And it's just easier. That's all. All right. Maybe you'll get the same answer. We'll see. Now I'm going to put it to the power of, not times by, to the power of 2. Isn't that the same as 2 over 1? Yeah, but you know that, and I know that, so it's just n to the 1 is equal to 4 squared is 16. Wait a minute, is this the kind where I could have a negative 16? No, but if you weren't sure, well, here's how you'd check. You put it back in the original. Or is it? Oh, let's find out. First of all, we think the answer is 16. Do you guys agree that the answer was 16? All right. Now I'm going to go back and put in the 16 and see if it really works. I don't want to do 16 squared because it's going to be a really big number. Do you get you can do it in either order? So instead, I'm not going to do 16 squared. I'm going to do that and then square it. What's the fourth root of 16? Could you have done the fourth root of negative 16? Fourth root of a negative wouldn't have worked. Oh, my brain is hurting. All right, so the fourth root of 16 is 2. Do you get that? The circled part there, the fourth root of 16 is 2. Yes? I agree. I'm going to check that in a second. So it's one thing at a time. Right now, the green thing that I circled there, do you get that the fourth root of 16 is 2? And then we're going to square it, which makes what? 4. And then we're going to add 6, which makes 10, and it worked, yay. And I agree. We should now check and see if... Oh, I know what happened. That's weird. I never have seen one like this before. But you're right. The negative actually also works. I've never had that happen. But because I made it one where you reduce it, you remember how it was 2/4 and we reduced that to 1/2? Do you get if you did not reduce it? Somebody asked me that. What if you didn't reduce it? If you didn't reduce it, then you would have put it right here to the flip it 4/2, and do you get we did do a square root? Whoa, we're not going to trick you that hard on the test. Okay, but yeah, there actually were 2 answers in this case. If a way to put it to the 4/2 power, anytime you do a root of 2, like a square root or even a fourth root, to both sides, you get 2 answers, and I didn't even ever notice that when you simplify this, you never have to put it to a root, and yet you still get 2 answers. Again, if we had that on a test, nobody would catch it. Everybody would get it marked wrong, so don't worry, we're not going to fool you on that. But let's get to the worksheet right now. I think you're ready. And it looks like this. Now I'm going to give you some that you can skip. You may skip 16, 17, and 18. 16, 17, and 18. And what else did I have people skip? Ah, yes, 7 through 10. And I'm going to get a clean copy of this to start it over again. But you may skip 7, 8, 9, and 10, and 16, 17, and 18. Pausing. Okay, so let's start this thing together now. I got a nice clean version of it. This really is good practice. Honestly, I did cut out several problems, but we need a bunch of these because they're just complicated. You can imagine this is one of your harder tests that's coming up. You know why? Because normally when your brain is this full of stuff, you're almost about to test. But yet we don't have a test for another week. So another week yet before we test. I'd say that at this point we've learned about half of the questions you'd have on the test. Most of the R2s you've already learned, not all. And probably half the R3s you've learned by this point. Like if I gave the test today, you could do most of the R2s and half the R3s. But we still need to learn some stuff about application problems. So you have another week before we test is my theme here. So yeah, this is complicated already, and we still have a whole nother week worth of stuff. Although of that week, one day is the test and one day is the review for the test. But all right, hopefully you saw this one and said, oh, square root of 4, I can do that, that's 2. And then 2 to the 5th, am I supposed to know that? Yes, you are. Memorize 2 to the 5th. It is 32 is correct. And do I expect you to do this in your head? I totally think a lot of you are going to do it in your head. It's okay. What you can't do is use a calculator. Because I get that you can just type these in a calculator and just get the answer like super fast. But then you're not understanding what you're doing. And when they use a variable, the calculator can't do it if there's an n in there. Okay, so you do need to know how to do this without a calculator. And I'm 89.6% sure that you're not going to have a calculator in this next test. I will find that out for sure soon. Okay, this one. Don't think like, oh, put it to the 2 over 1. We're not solving an equation here. We're just finding the answer. So what does this half power means? That means square root. What does this negative mean? That means reciprocal. So square root and flip it. Go ahead, write down what you think it is. You're going to square root and flip it. Square root at the top, square root at the bottom, flip it. Row 2. Last person. You are correct, because you took the square root, which was 5/3, but then you flipped it. Right? All right. Okay, next one. 3rd root of 125. These have to be like butter. What is it? 5. And then you square it. What's that? 25. And then you reciprocal 25, and you get 1 over 25. This next one, I would do this because right off the bat, I'm asked to do the 3rd root of 16. And if they ask me something like that, I'm like, wait a minute, I don't know the 3rd root of 16. That's not an easy one, so they must have some other way to do this. So I'm going to multiply those 2 powers. You remember that, right? If it was a to the 2nd to the 5th, it would be a to the 10th. You would multiply that kind. Okay, so if we're multiplying that, it's 16 to the 9/12. Can you simplify those? Yes, you can. And then you'll be able to do it. Because it's going to be asking for the 4th root of 16, which you do know. 9/12 is the same as 3/4. I showed the work there. And now I can do the 4th root of 16 and then put it to the 3rd. All right, this is the part where I need to drop out and let you guys work. I did say you could skip 7, 8, 9, and 10, but what if you need more practice and I did a lot of them for you? You totally can do more. I'm not saying you can't do them. I'm just allowing you to skip them. All right, now one warning. When I see this problem, I'm a little bit suspicious that there might be something going on, okay? So if you're at the ball game, if you're just wearing a simple shirt and pants and you walk up, they're just going to take your ticket and let you go in. If you're wearing a big baggy coat and have a backpack, they don't let you walk into the ball game that way? Because they're like, I wonder what he has in the backpack and what could he have under that coat? So my point, I'm suspicious of this problem. Watch out for it. Because it has square roots on both sides, a lot of times you get an answer, follow all the rules, which is, by the way, square both sides. That's totally legal, and it gets rid of the square roots. But then you get this answer, and it turns out the answer doesn't work. I'm not saying that's the case, but I'm saying that happens a lot, and the same thing's going to happen in pre-calc. You get an answer after following all the rules, and yet it still doesn't work. And you know how you could have caught it? Let's say you're at the end and the answer comes out to x equals -10. How could you catch that it doesn't work? You put it back in and see, oh my gosh, it's telling me to take the square root of -86. And that's not legal. You can't do a square root of a negative. You see what I'm saying? So watch out for that type of question on the test and in pre-calc, because anytime you have square roots on both sides, it often happens, not always. It's like this weird 50-50 thing. Sometimes you get the answer and it just works and it's fine. And other times you get the answer and it doesn't work. Even though you didn't break any rules in solving it, the answer is called extraneous. I have this good story about extraneous, but I'll share it a different day because I want to get to that the girls' state game in your work time. So this is the part where I believe you can do this, but I also you're going to get confused sometimes. Please feel free to stop up and say, I'm stuck on this one, and I will help you. We have a week before we test. Just ask me if you get stuck. That's all I have for you for today.